All right, so here I'm sharing my other screen, which is wider, so you can see the full Windows desktop, which is kind of big. And let's talk about Velociraptor. Velociraptor is a tool for incident response, and therefore it includes a lot of what you call computer forensics, gathering evidence off machines. And the best way, you can put the server on Windows, but it's very slow on Windows, and you have to have a lot of system resources. It runs better on Linux. So I've got instructions here of how you can set it up on a Debian machine, which is really very easy. Velociraptor just has it's an open source free product, and it was acquired by Rapid7 about a year ago, which I think is very good for it. Rapid7 has been a very good steward of Metasploit, for example. They really do support these open source projects and keep a free version. I imagine they'll make a pay version that's better, but the free version is excellent. So you just go to this page and you can download versions of it for any operating system. Like here, the first one is for Linux and the next one for Windows 64, and there are other ones. And the executable that you use is the same for the client and the server. It's very simple. And so to prepare the server, you have to create a configuration file, velociraptor config.yaml, which is pretty common. And then you have to change the IP address, because by default, it will only listen on the local host address, which is common for security tools. They want you to administer it only for the browser right on that server. And that's often not what we want to do. So you can change that to a public address everywhere. And then when you start it, it will just print out this page showing you that the server is running. And the server is going to, after it starts a whole bunch of processes, it's going to show you it's ready to handle TLS requests on port 8889, and the front end is ready on port 8000. So port 8000 is used for clients to connect back to the server, to send data and to receive commands. In a sense, this is true of all these all these domain controllers and other tools. It turns your other machines into sort of bots in a bot army. They're under remote control of the server to some extent, and that's true of Velociraptor as well. You have to put an agent on the machines you're monitoring, and then they can receive commands from the Velociraptor server. And they send that back to the server on port 8000. Port 8889 is the GUI. You can open in a browser. So you just open a browser and you see a nice little web page where you can control the Velociraptor server from here. And this turns out to be very, very nice. All right, and if you're doing it on Azure or other cloud servers, then there are considerations with the cloud firewall. You have to open those ports. So to make a Windows client, you use the same Velociraptor executable to create, well, you need the Windows version of the client, which you'll see you'll create it. First, you have to make a configuration file. And the one thing you'll have to change is tell the client to expect the server to use a self-signed SSL certificate, just because we are not putting a real certificate on there. Now, these days, we could get a free one and put it on and make it a real public server, but I didn't put that in the project. So we have a self-signed server, and so you don't want the clients to stop because they reject their certificate. So you have to add this line to the configuration file, so they won't. And now to create the Windows installer, you take the Linux version, which is running on your Linux machine, and with the configuration, you then create the client configuration and you repack the exe. So you create a Windows executable client that has your server's address included in it, which is the same thing malware does. When you download malware, it runs and it knows how to find the command and control center server in there. And so does this. And then you just have to move that exe file to your Windows machine and run it. And because my students are often using cloud machines and virtual machines that are hard to move around, what I did was I showed you how to do it with WinSCP. You can use a network connection to move it over, and then it doesn't matter if you're putting them in the cloud or anywhere. But you could somehow you could email it to the client, or somehow you get it on the client, and then you just run that executable with an administrator command prompt, service install. And it will then run that service on the Windows machine, and it will be controllable by the Velociraptor server. So I've got that all set up here. And let me get here's my Velociraptor server. This is my Debian Linux machine. And here is the window where it's running the Debian the terminal. I just ran it in the terminal and I'm letting it print messages here. You could run it in the background or something, but this is good enough. It's showing every request. Here's the GUI. So if I go home, it loads this home page that shows me a graph with server status and the number of connected clients. And what's more interesting than that for what we're doing is to go up here and show all. This will show all the connected clients, and there is a connected client running Windows 10 Enterprise. It gives it some kind of arbitrary ID number. If you click on that, it will now show you information from the client. And you could now interrogate it in various ways. You can interrogate the file system and other ways. Here you can interrogate things like, let's see, I'll make this bigger, Control Plus maybe. Yeah. Here you see files, NTFS. You can interrogate the registry directory, directly. You could explore the Windows machine directly from this window, but that's kind of inconvenient and slow and not the best way to do it. We'll do some other things later. But before, let's take a look at the Windows machine, which is here. Now, I put some fake malware on this machine. I wrote some simple little scripts that do irritating things that don't really hurt the machine. This pops up a box saying your machine is pwned, and so we're going to research that. But you can tell that this is connected to the Velociraptor server by looking in services. If you just open services, then down towards the bottom will be, it's an alphabetical list, VW. There it is, the Velociraptor service is running. I run the executable on this machine, so it installed the service and it will automatically start when you restart it. So this machine is connected to the server until you remove that service. So that's what's being used to show that connection from the other machine. And so once you've got that set up, I made several projects where you get to practice investigations. And the one I set up just before you came back was this one, investigating potentially unwanted program with Velociraptor, a relatively harmless piece of malware. You just download this zip file and run it and delete it according to the instructions. And now you have, that are these attack techniques from the attack matrix that we talked about. And so the scenario is this: your user complains that they have this irritating box on the machine, and that's all you know. You know, it puts up this message, your machine is pwned, and they are far away. All you have is the Velociraptor server to investigate that. And here's how you might do that. You'd start with auto runs. Whatever that is, it automatically launches when you restart the machine. So you can run auto runs from Velociraptor. So you go into, here, okay. And I'd go home, back to my client, show all, and my client. Okay, and now I hit collections. I think collected will do. Yeah, now I can collect things from this server, and I'm going to make my desktop bigger, I think. All right, there we go. And even bigger yet would be good. All right, and maximizing this. That's not what I wanted. I wanted to maximize the browser, which is here. Okay, there we go. All right, so now I can add things here. I can just search for interrogations to perform. So I hit the plus sign, and then I search for Windows sysinternal auto runs. So plus means a new collection. And now I can try putting like auto runs here. It'll find ones that match. There it is, Windows sysinternal auto runs, a Microsoft product to find out what's automatically launching on your machine. Here it tells me how to use it. It requires, it's going to download the binary and install it on the Windows machine automatically. And then it's going to run it. And I could add more parameters here. But if I don't add any parameters, it's going to give me a list of all the things that automatically run. So I'm just going to launch it with the default parameters. So I take auto runs and click it to select it. So it highlights and then launch. Now what this does is actually pretty clever. It doesn't just request this one machine to run it and wait while it answers. It creates an asynchronous hunt. You could have selected 1,000 machines to run this on, and it would send a request to them like an email that says, run this and send it to me when you're done. And then the server is free to keep working. And then the responses will all come in asynchronously, and it'll gather them as they come in. It's designed to handle that situation where you might have many machines. Now, it'll take a little time to run. You can click on it up here, and down here you can see the response. So, for example, you can look at the log and see what it's been doing. It started query execution. And let me try to make my window taller. Okay, so it removed a temporary file, and it's going to download auto runs. It found the auto run somewhere. It downloaded it. It's fetching it. It's going to install it. Then it's going to run it. And it's done a lot of stuff. It's 14 rows. So they made it down. It's sending response. So it is running it. Here's where it executed the auto runs with some parameters. No banner except ELUA and other such things. And then it's going to start sending me data. And it may take a little while, like a minute or two, because it turns out it has to send me quite a bit of data. It's done. Okay. So I can, it's okay, 1 of 14. Let's get the response, which is going to be here, results. All right. And I'm trying to work with my screen's a little small here. Okay, here it gives me a list of things: entry location, image path, the registry key that's launching it, and so on. It's giving me a lot of information in a very unfriendly format. So I want to download it in a better format, and there is a way to do that. You click the button there. They'll download it in CSV. That is one of these. Download CSV. There we go. All right, so I can save this. And it looks like it's automatically going to open in LibreOffice. That's not bad. It just depends on how your Linux machine is configured. Now I have a Microsoft Office or a LibreOffice document showing all these items in it. All right. And what you want to do is find the run key used to launch pup4 message. And so it's in here, and I should be able to find it in LibreOffice with a find button. Let's see, edit, find. Okay, there's the find button at the bottom, pup. Probably going to be the only pup. And what do? I have to press enter maybe? Yeah, there it found something called pup4 on this line. And so if I scroll to the left, there you are. It is HK local machine software WOW64 to 32 node, which by the way is a suspicious thing. That means it's 32-bit code running on a 64-bit machine. And then the run key. So there's a run key named pup4 there. And there should be more information if I scroll to the right, enabled. And here's some hash values. And I think there it is. There's the actual path for it. See pup4 message. That's the actual executable that has run here. So I have found something called pup that is automatically launched from the root of C. It's 32-bit code running on a 64-bit machine. It doesn't look like a commercial program or anything. So it's moderately suspicious. In particular, it's not signed by anybody. I think this shows me the signatures. Let me scroll and see if I can see it. Image path, company. See the company right there. The company there is the company that signed this code. If it was from Microsoft or Cisco or somebody, that would be here. But that line is not signed at all. So that's another suspicious thing. So it might be a bad thing, but I haven't by any means proven that it is responsible for making that box. So we can get the exe used to launch the process by running Windows System PS list. So let's get rid of this and run Windows System PS list. Again, I can just put in PS list or any part of the string. It will find it. Windows System PS list. This lists all the running processes. So again, I can just run it without configuring any parameters. And it is done. I select it up there. I'll see the results here. Again, I get a lot of results, and it's kind of hard to read here. I'm going to try again to make this window bigger. It looks like my Linux desktop is not letting me get bigger easily. So let's see if I can run that again with better parameters. I'm going to launch PS list. I know the process is called pup4 or something like that. And I think I can restrict it to show me only that process. If I go to parameters and the wrench, I can now give it a process regular expression. And I hope I don't have to write much of a regular expression. I think I can just do pup here. And I think it will accept that as just a pattern to match. Let's see if that works. Then it will give me only information about processes that contain the string pup. And that should be a shorter list. And it is. See, pup4 message.exe is here. All right. So you can see that process is currently running. And there's the authenticode signature, which does not contain anything because it's not signed code and so on. All right. And there is a way to get the MD5 hash, should be over on the right. I may not be able to see it in this small window. If I scroll to the right, should be there. I'm a little troubled that it isn't, but I'm not going to. Oh, there's the hash. That's it. MD5. It's just awfully hard to see here in this little window. Why it might be nice to connect to this outside, which is what I think I'm going to do. The only other machine on that network I could use, though, is the Windows machine, which I guess I could do that. 192.168.11.24. Let me try that for my demonstration. Let's open a browser. Okay. And HTTPS, I think, 192.168.11.4, and I think it's 88.89. And I'm going to get rid of all that extra stuff. Okay, this might work. All right. Oh, I don't think it was 11.4. Let me go to my, it was, yeah. Whoa. Well, that's still the same machine. That's why. Where's my Linux machine? All right, what's going on here? Okay, it's 11.24.88.89. Okay. Back to my Windows machine. '24. There we go. And when configuring it, I had to give it a username for the administrator account and password. There we are. Now I can control Velociraptor from here and I can make the window bigger. All right. So it's a little strange. The Windows machine is controlling a Linux machine, which is then going to ask the Windows machine for information. So it is a little convoluted, but anyway, it'll make the demonstration look a little better. So show all. There's my client. Now I can go to collected and add another Windows system PS list, although I might just be able to view the results of the last one in a friendlier window. Here's results. Yep, now it's easier to read. Now you can see it's got the MD5 there and the SHA-1 and the SHA-256 hash of that, that running process. So all I've done now is I've proven that that process launches at startup, and I've gotten the MD5 of it. It's currently running now. So I could put that in VirusTotal and see if it's known malware, but it isn't because I wrote it. So now we want to prove that that running process is in fact printing the message that says you are owned, you are pwned. So we can try to harvest memory with Windows triage process memory. So let me go to here, add another one. And this is going to be Windows triage process memory. All right. And I'm going to configure parameters to tell it which process to get. And again, the default is Notepad, but I want it to get processes that contain the word pup. And that'll probably do it. Let's launch. I click here to see the results. and it's already done. And here it is. It has made a dump file, which contains the process memory. And you see Windows temp dump file. And I can use strings to look in there in principle. I can probably just open it in Notepad since I'm on a Windows machine. I expected to be analyzing it on a Linux machine, but I decided to use Windows here to make it look prettier. So let's just open C Windows temp dump. I'm going to copy this path. And then open Notepad. And then open it. Hopefully I'm not going to need administrator privileges to open it, but we're going to see. Control V, enter. Continue to gain permission. That would be nice. File not found. All right, that's rude. C Windows temp. Oh, because it's text documents, probably all files. Okay. Nope, it's still not there. Well, that's annoying. All right. I am not sure what the problem is. Full path. Crash dump. Maybe I have to get it elsewhere. Let me take a look here. Move the dump to a Debian for safe. Acquire the memory. Okay. Just a moment. Let's go to uploaded files. Okay. It's actually a longer, complicated path. I can download it in the browser here. Okay. That path was where it stored it temporarily while collecting it, not where it stored it for analysis. Now it is downloaded, so I can install it, so I can view it. And I could open it on a Debian machine for analysis, but I should be able to just open it in Notepad to see the strings. That'll do on this Windows machine. Open with another app. More apps. And hopefully they're going to give me a choice for Notepad. There we are. They are going to give me a choice for Notepad. There. All right. And now I can look for that message, which was "you are pwned" by double bed. So I could just use Control F and search for pwned. I didn't find it, which is what I was, because it's probably Unicode. So I might put it, I think I won't continue, but if you put it on a Linux machine, you can find strings here. And if I used a hex editor, I could find it that way. It's Microsoft Unicode, not ASCII. And you'll find these messages are in that file, in the Microsoft format, 16 bits per character. And that proves that the running process really is that process you saw. And now you can see if other exe files on the machine are also involved. You can use Yara, which is a very common tool for malware analysis. Yara is basically like grep. It just matches a pattern of characters in files, and you can search through all the files for certain characters to see if they are associated with a known malicious file. So you can just search for all exe files containing the Unicode string pwned, and you'll see that here, Windows detection Yara NTFS, and then you'll find them. And when you try to do remediation, Velociraptor has the ability to open a shell on the target and fix it, but it doesn't seem to work. And the developers were kind of reluctant to include that feature, so I think they limited it. So in fact, to remediate it, you'll have to execute these commands directly on the client. That's how you clean off this malware. Anyway, that's an example of the kind of investigation you can do. This is a very good tool for students because you get used to the typical forensic artifacts that you hunt for on machines, and you get to practice them. There's a bot and a two-stage rat. And so there's a few options here where you can practice doing incident response with Velociraptor. So it's a lot of fun, and you might want to set it up if you're willing to set up a Linux and Windows machine and go through a few relatively simple steps to set it up. So that's it for this one.